Okay, welcome to NEET level chemistry classes. Today I am discussing about alcohols, phenols, and ethers. Let's take a question. Okay, an ether is more volatile than alcohol, having the same molecular formula. This is due to intermolecular hydrogen bonding in alcohols. Because alcohols are polar molecules, they will have a uh, hydrogen bonding is forming. That's the reason uh, it is required higher temperature to break the inter hydrogen bonding. That's the reason option A will be the correct answer. Whereas alcohol does not possess. Of course, they are polar, dipolar. If we are looking at the dipolar character, ethers will have a less dipolar compared to the alcohol. Alcohols having resonance. Definitely, resonance structure is not the right answer for this high boiling point. And intermolecular hydrogen bonding in ether. Less strong force between the inter molecular hydrogen bonding is observed in ether. So right answer is the intermolecular hydrogen bonding for the this makes the alcohols to have a higher boiling point. Let's take another question. So which reagent can distinguish ethanol and phenol? So here acetyl chloride is the better reagent. Using this acetyl chloride, it is possible to distinguish between ethanol and phenol. Why? Because once acetyl chloride is added to ethanol, it immediately effervescence is observed, whereas acetyl chloride is added to phenol, a slow reaction occurs. That's the reason this is the right answer to right reagent to distinguish between ethanol and phenol. Thionyl chloride is not, because thionyl chloride is reactive both acetyl chloride as a uh, phenol uh, in a similar way. Similarly, acetic anhydride also react in a similar way with both ethanol and phenol. Acetic acid does not react with the both ethanol and phenol at low temperature. That's the reason acetyl chloride is the one. Using this reagent, it is possible to distinguish between ethanol and phenol. Acetyl chloride immediately react with the ethanol gives effervescence, whereas the phenol slow reaction. That's what the. Let's take one more question. So maximum dehydration takes place in that of here a cyclohexanone hydroxy 2 hydroxycyclohexanone is the right answer, because there is a enol formation possible in this. Here there is a in between CH2 is there. So that's the reason this is having less possibility of dehydration. Similarly, this is electron releasing group, so electron density increases on this. So here less possibility. Here also in these two, enolization is less possible. Option C and option D, enolization is less possible. Here enolization is more possible. So enolization makes the 2-hydroxycyclohexanone is the maximum dehydration. That means more feasible for the dehydration compared to all other options. Let's take one more question. So here, which reaction occurs? The first one, name of this compound is called paracrozole. Paracrozole on treatment with the concentrated HCl on eating, no reaction at all. Similarly, paracrozole on reaction with chlorobenzene in presence of aqueous amine. This comes under nucleophilic substitution, aromatic nucleophilic substitution. So you know that aromatic nucleophilic substitutions are possible only when electron withdrawing groups are attached. Here, electron donating group is attached. That is the reason nucleophilic substitution and the aromatic substitution is difficult, because chloro is attached directly to the benzene ring. Replacement of chloro is difficult because there are no electron withdrawing groups are present on the benzene. That's the reason this is also not possible. Whereas this one is possible because aqueous sodium hydroxide react with the phenol, forms a phenoxide ion. Phenoxide ion react with the one of the methyl. That means it's a methylation reaction. O methylation. This reaction is possible compared to all other one. Let's take one more reaction. So here elimination means dehydration reaction. The main product of the following reaction is, so here you can observe that this CH2 is called benzylic proton. The benzylic protons are more acidic compared to the secondary tertiary proton. So this proton can be easily removed using the concentrated sulfuric acid. So once this proton is removed, then there will be a double bond formation between this carbon and this carbon. And one more possibility here, two things, one is cis and another one is trans. So if we are looking at the stability wise, trans will be the more stable compared to the cis one. That's the reason the right option for the product formation will be the A. So because benzylic protons are acidic nature, so easily removed, dehydrated, forming a alkene, and the obtained alkene is a trans one. Why? Because thermodynamically trans ones are more stable. And this option is ruled out because removal of proton on this carbon is difficult. Similarly, this option, removal of proton on this carbon, is difficult because they are less acidic compared to the benzylic acid one. That's the reason option A is the correct answer. Let's take another question. So here in the following sequence of reaction, so ethanol is there. Ethanol on reaction with iodine in presence of phosphorus. So what it will do, it replaces the OH with the iodine. That means A is iodoethane. Then iodoethane on reaction with magnesium in ether, it's nothing but a Grignard reaction. So the obtained one is ethyl magnesium iodide. So ethyl magnesium iodide react with the formaldehyde, gives rise to ethyl oxy magnesium iodide. This ethyl oxy magnesium iodide on hydrolysis gives propanol. So N-propanol will be the answer. Butanol is not the one. Why? Because you can observe that 1, 2 and 3 carbon atoms are there. Here butanol means 4 carbon atoms. Similarly, butyl alcohol means 4 carbon atoms. So it's not possible from this reaction. Propanol, it's an aldehyde one. Aldehyde is not forming because a Grignard, when it is react with formaldehyde, alcohol will be the product. So right option is N-propanol will be the right answer. Let's take one more reaction. So the alcohol manufactured from the water gas is methanol one. Why? Because methyl alcohol is nothing but a methanol is prepared by passing hydrogen gas in water in the presence of catalyst. Why? Because carbon monoxide react with the hydrogen in presence of a catalyst gives alcohol. This is nothing but one of the environmental green chemistry where a gaseous molecules are converted into liquids. So ethanol is not forming because water gas does not contain two component one. Propanoic acid also not formed because there is no such conditions in the water. Similarly, isopropanol also not forming. Let's take one more question. So here again a dehydration process. You can observe that this is the primary carbon atom and this will be the secondary carbon atom. So removal of proton from the primary carbon atom is difficult compared to the secondary carbon atom. That's the reason removal of proton on this carbon and removal of H and OH minus, it's going out as a dehydration. The obtained double bond between this carbon and this carbon. So the answer is B. So here it is explained. So removal of proton on this carbon, so forming a major product. Removal of proton on this carbon will be the minor product. Let's take another example. So here it's a what you call Williamson's synthesis. In the Williamson synthesis, reaction of chlorophenol. This is the chlorophenol reaction with the diiodomethane in presence of base. So gives rise to acyclic cyclic compound. That means O methylations. So this will be the product. So how this product? It is based on the Williamson synthesis. Why? Because name of this compound is catechol. Catechol in presence of sodium hydroxide, it forms a dianion. So this dianion react with the diiodomethane. That means two iodines are replaced with two oxygen. So that's the reason this is forming. Here there is no one more. The position of hydroxy is different here and here. This is the one is ruled out. So the here OH is there and here CH2 high is there. This position is ruled out. And here one side methoxy is there, one side hydroxy. This is also ruled out. Let's take one more question. So here, which one of the following is cleaved by hydrohydric acid? So hydrohydric acid is the oxidizing agent which cleaves selectively a 1,2-diol. So glycerol contains 1,2-diol, so it will cleave glycerol. Glycol contains 1,2-diol. That's the reason HiO4 cleaves the glycol, whereas propane 1,3-diol and methoxy 2-propane-diol. Here one of the only one hydroxy group is there, but here hydroxy groups are too far, means 1,3 position. That's the reason C and D compounds are not cleaved by hydrohydric acid. That means option is D. Okay, let's take another question. So here ethanol is converted into acetaldehyde in the presence of. So normally whenever sodium dichromate is there, name of this compound is sodium dichromate. Acidified sodium dichromate will be the reagent for the conversion of ethyl alcohol to acetaldehyde. So alkaline potassium permanganate will be the right answer for the conversion of alcohol to acetaldehyde. But here there is no permanganate. Since it is a potassium dichromate, dilute means acidified potassium dichromate will be the answer for this. That means option B will be the answer for the conversion of ethyl alcohol into acetaldehyde. Let's take One more question. So here the enzymes which are used to convert the starch into ethyl alcohol is the diastase. Diastase is the enzyme which converts ethyl starch into alcohol. Similarly, maltase, it's the enzyme, it can convert the starch into ethyl alcohol. Similarly, zymase is also an enzyme which can convert starch into ethyl uh, alcohol. These are not the right answers. Let's take one more question. The compound on dehydrogenation. So here you have to remember that dehydrogenation means removal of H2. So removal of H2 is possible. Removal of H2. On removal of H2, a ketone should be product. So secondary alcohol removal of H2 will give you the ketone, whereas the primary alcohol removal of H2 gives aldehyde. So secondary alcohol, tertiary alcohol does not give you the oxidation, dehydrogenation itself. Similarly, carboxylic acid does not give you the dehydrogenation at all. So the right answer is secondary alcohol. That means one hydrogen from here, hydrogen from here, removal of H2. It's possible in presence of catalyst. Then let's take one more reaction. So choose the correct statement. Ordinary ethyl alcohol is also known as rectified series. It is true. The alcohol sold in the market for polishing etc. is known as methylated spirit. Correct. Absolute alcohol is 100% alcohol. Correct. Power alcohol is 100% ethanol. This is the wrong one because power alcohol means it's nothing but a 20% of ethanol and 80% of gasoline. Usually the Reliance industry is using this, right? Then the products obtained when anisole is heated in a sealed tube with HI. HI means it's hydrohydric acid. Anisole means it contains ether. So ether cleavage using the HI. So when ether is cleaved using the HI, so it will give you the uh, phenol and methyl iodide are the product because this is the anisole. So anisole means OCH3 bond can be cleaved using HI, so gives rise to phenol and methyl iodide. So these options are not correct answers, so option A will be the correct one. Let's take another question. Which one of the following gas is liberated when ethyl alcohol is heated with methyl magnesium iodide? So we know that methyl magnesium iodide are sensitive to alcohol and water. So these decomposes to give methane gas. So here is an example. This is the methyl magnesium iodide. It's a Grignard reagent. So it will what it will do, magnesium iodide form a bond with um, alcohol, then this CH3 is going out as a methane gas. Okay, let's take another question. So which one? So in the reaction, right, so in the reaction ethanol treated with copper at 300 degree to gives a product called X. The molecular formula of X is, so here you can observe that alcohols are oxidized by not copper to give aldehyde. That means uh, aldehyde will be the product. Aldehyde is nothing but a C2H4O. That means here a molecular formula is given, not the structure. So this molecular formula C2H4 is nothing but a acetaldehyde formation. So acetaldehyde, here as I mentioned, there will be a loss of H and dehydrogenation, removal of H2 is possible. So that's the reason product is obtained. So option C will be the answer. Let's take one more question. Alcohols cannot be prepared from option D. Why? Because methyl chloride on reaction with water, it will give you the this is not the right answer, because in all other options alcohols are prepared. So reduction of ketone alcohols are obtained. Then similarly, aqueous sodium hydroxide can replace the bromine, form a product. Similarly, reduction of ketone also give the alcohol, but this is does not. Okay, this requires a reagent like silver oxide, then it is possible. On heating is possible. Not only with the water, it's not possible. So let's take the cleavage of an aryl alkyl ether. That means, so on either side of the oxygen, one group will be aryl group, means aromatic benzene group, and the other group will be the alkyl group. So in such case, when aryl alkyl ether is cleaved using the HI, the possible products are phenol and alkyl iodide. It means that iodobenzene is not forming. Iodo is only forming the bond with the alkyl group. So that's the reason option D will be the correct answer. Let's take another question. Acetic anhydride reacts with the diethyl ether in the presence of anhydrous aluminum chloride. This reaction is used to cleave the diethyl ether and to form an ester. So that means ethyl alcohol. This is the formula for the ether, diethyl ether, and reaction with acetic anhydride in presence of Lewis acid, that's called aluminum chloride, to form an ester. What is happening here? The lone pair present on the ether react with the acetyl source of the acetic anhydride, thereby forms a ethyl acetate. Let's take another question. So which of the following represent the Dow process for the manufacture of phenol? So the Dow process means reaction of chlorobenzene in presence of sodium hydroxide at a 300 degrees centigrade and 200 atmospheric pressure. So it will give you the phenol or the product. So that's the reason option A will be the correct answer. So what is the difference between here and here? So here the temperature is given in SI unit called 623. Here the temperature is given in degrees Celsius. That's only difference. 200 atmosphere, 200 atmosphere. So in other places atmosphere is not matching. That's the reason option A will be the correct answer. Let's take one more question. So here again, this is again breakage, means ether cleavage. That means reactions of ether. Then anisole. This is nothing but a anisole. Anisole and reaction with HBr, there will be a cleavage, between ether cleavage. That means OC bond cleavage. The obtained product is phenol and methyl iodide. Let's take one more example. So in the reaction, so here a methyl alcohol is oxidized to give initially converted into formaldehyde, later converted into formic acid. The obtained formic acid on reaction with ammonia, it will give you the ammonium formate. That's the reason option B will be the correct answer, because A is formic acid, B is ammonium formate. This is the one. Let's take one more question. So phenol is soluble in water because of intermolecular hydrogen bonding. That means phenol is forming a intermolecular hydrogen bonding with the water molecule that makes the phenol to soluble in water. Then phenol on reaction with sodium nitrate in presence of H plus, it will give you the product B. So which on hydrolysis give you the product C. So this on treating with an aqueous gives D. So this is called Lieberman's reaction. Lieberman reaction means phenol react with the sodium nitrate. This is called nitrate in presence of H plus. So this equation I am not given, but you can check the Lieberman's reaction. Phthalate reaction means here the reactants are not matching. For Rimmer-Tamer and Scott-Bowman reagents are not matching. Lieberman is matching. That's the reason option A is the correct answer. Then let's take one more question. Alcohol can be converted into acids by the following sequence. That means alcohols on reaction with the what you call a tribromophosphine, a OH group is converted into bromo. The bromo will be replaced with the CN and the CN will be hydrolyzed. That means you can observe that here 2 carbon atom and here 3 carbon atom. It is possible by the addition of Cn. Cn is hydrolyzed. Here nitrogen is going out as ammonia. That's the reason option A is the correct answer. Whereas the other things here hydrogen reduction is possible. Reduction means what you will get alcohol you will get. That's the reason option 2 is wrong. Similarly here conversion of alcohol to bromide is not done. That's the reason this is not the correct answer. So first treating with HCN with the alcohol is not the right process. So option A will be the correct answer. Let's take another one. So which one of the following will most readily dehydrated in acidic media? You can observe that here this proton what you call active methylene group. This carbon is called active methylene carbon. The protons present on this carbon is called active proton. So this atmosphere is not found in the other substrate. So this is active hydrogen containing moiety. This is more feasible for the dehydration. So option A will be the correct answer. Let's take one more question. The correct order of the acid strength of the following compound is phenol, cresol, metanitrophenol, and paranitrophenol. So you can observe that. So the substituent present on the phenol can increase or decrease the acidic strength. If there is an electron donating group, acid strength is decreases. If withdrawing groups are present on the phenol, acidic strength increases. That's the reason. Fourth one. What is fourth one? Paranitrophenol is more acidic compared to the metanitrophenol. Metanitrophenol is more acidic compared to the phenol. Phenol is more acidic compared to the paracresol. This is because of the electron donating nature. So paracresol means CH3 is the electron donating group which is present. That's the reason this is less reactive. Let's take one more question. So phenol, propane 1-ol. Propane 1-ol means that is nothing but a N-propanol can be prepared from propene. So that means here propene means double bond is converted into alcohol. That is possible with the oxymercuration followed by reduction. This method is called oxymercuration. Option B will be the correct one. Why? Because Hg will add to one carbon atom. O acetate will add to another carbon atom. So the Hg will be replaced with the OH when the oxymercurated one is treated with the sodium borohydride. So here is the reaction. Double bond react with diborane followed by followed by H2O2. That means this is the correct answer. Option C will be the correct answer. That means a double bond react with borane. You know that borane BH3 will add to terminal carbon atom, and that BH3 is replaces with hydrogen peroxide, gives rise to alcohol as the product. Let's take another question. So salicylaldehyde is obtained when phenol is heated. That means it's a Reamer-Tamer reaction. In the Reamer-Tamer reaction, phenol on reaction with chloroform and sodium hydroxide gives rise to formaldehyde. That means this chloroform can act as a carbene one. So that means chloroform and sodium hydroxide gives rise to carbene. That carbene add to this carbon and forms an aldehyde. This is not a carbylamine reaction. Carbylamine reaction means it is related to isocyanide formation. Hoffman reaction means it is related to conversion of amide to amine. Kolbe-Smith. Kolbe-Smith also not related to acid salicylaldehyde formation. Let's take one more reaction. So in Williamson synthesis, ethoxyethane prepared by. So ethoxyethane prepared by sodium ethoxide on treatment with ethyl bromide gives rise to ethoxy. This group OCH2CH3 group is called ethoxy. CH3CH2 is called ethane. This is the IUPAC name of ether group. Diethyl ether IUPAC name is ethoxyethane. So ethoxyethane is obtained by Williamson synthesis. Williamson synthesis, option B will be the heating sodium ethoxide with ethyl bromide is the reactant. This is nothing but a Williamson synthesis. Heating ethanol in with dry, this is not the required one. Similarly, this is not. Similarly, ethanol overheated alumina, this is also not. Okay, let's take another question. So here again I am taking alpha beta unsaturated aldehyde. This is called alpha beta unsaturated aldehyde. So a reagent X is added to get a alcohol. What it means? You can observe that aldehyde, this the aldehyde group is there and alpha beta double bond is there. So in presence of double bond, only aldehyde groups are reduced. That is possible with the sodium borohydride. Sodium borohydride selectively converts carbonyl compound into alcohol. This sodium borohydride does not affect the double bond. So here this is called stereoselectivity. Stereoselectivity is possible with sodium borohydride, which selectively convert aldehyde into alcohol. It does not alter the double bond, whereas hydrogen in nickel, this also reduces double bond as well as the carbonyl compound, and this is an oxidizing agent, this is not a reducing agent. So that's the reason these options are wrong, but option B is the correct one. Let's take one more question. So formation of diethyl ether from ethanol is based on. So dehydration, here the option is the dehydration reaction. That means formation of diethyl ether from ethanol. That means ethanol on subjected to dehydration in presence of concentrated HCl. That means H from one ethanol, OH from the another ethanol, water is removed. That water is taken by the sulfuric acid and diethyl ether is the product obtained. This is about the one class of alcohol, ethers and phenol. I will also continue few more classes. I will stop at this stage and I will continue in the next class.